Okay, hello guys. Today our topic is about factorization. We're talking about the common and groupings. Okay. So first of all, let's move into and understanding what is a factorization. Okay. So we knew that factorization means that maybe we have a polynomials, right? Or maybe we have many terms inside the polynomials. Like we have 2xy plus 2y, right? And you'll find that they have the same factors, 2 times y, right? Okay, so you can just put 2y aside from the polynomials, okay? So here, you can write that as 2y, and here is x plus y, okay? That is these equations. And we call this a factorization. And also, sometimes we have to using the expansion method, right? Okay, like we have this times of 2y times x plus 1, right? So you can first times 2y with x and also make a product with 2y and 1, okay? So final answer is 2xy plus 1, okay? So right here, we're learning to how to extracting the highest common factors, okay? Maybe here you can find there are 12x cubed y minus 18x squared y squared, right? Okay, so you can find here we have 6, right? We have 6. And 6 is a common factor between 12 and 18, right? Okay, this is 6. And for x squared, you can find here as x squared, right? X squared, because x cubed and x squared, they both have a common factor, x squared, right? And also for y, maybe here y and y squared, they both have a factor y, right? Okay, so here we can set 6x squared y as a common factor between 12x cubed y minus 18x squared y squared. Okay, so here you can just write that as this one, like 6x squared y. And then you can use in like the first term 12x cubed y to divide it with 6x squared y. Okay, so here 12x cubed y divided by 6x squared y, and the answer here is for 2x, right? And here 18x squared y squared, you can use in 18x squared y squared to divide it by 6x squared y, right? So there, the answer is 3 times y, right? Okay. So here, the example gives our outcome that is 6x squared y times 2x minus 3y. Okay, so that is for this expansion polynomials. Okay, so also like here, if we have a brackets, we can make them to become a, because they have a common factor, we can both retract them. And here you can find 2a times x plus y and 3b times x plus y. So you'll find they have both a bracket x plus y, right? Okay, so here we can say, oh, first we extract an x plus y outside of the brackets. So it becomes x plus y. Here's 2a minus 3b, okay? X plus y times 2a minus 3b, okay? So here you can just put them into two factors and they times together, okay? So we can call this like a factor, also a factorization problem, but sometimes it's harder for us to find it. You can find they have a common factor, okay? But sometimes common factors is very hard to find, okay? So here, also like a factorizing by grouping, okay? So you can find this. If you want to factorize these polynomials, maybe it's very hard for us to first determine what is the common factors, right? You can find x squared, 3x, 2xy, 6y. If you both determine for 4 common factors, you're harder to find it, right? Okay. So here you can just making them into grouping. Okay. So first, x squared with 3x. Okay. X squared with 3x. You can first extract the x, right? So here I can write that as x times x plus 3, right? And you can find there are still two factors left, right? One is 2xy and another is 6y. Okay, so then you can extract for 2y, right? Okay, so here is extracting 2y, and here is x plus 3, right? Okay, so here after extracting, so here is x plus 2y times x plus 3. Okay, that is here. So is x plus 2y times x plus 3. Okay, that is factorizing by grouping. Okay. And maybe here also have some grouping with a negative signs. And you can find here, the example is about factorize 2am minus 4bm and minus 2an and then plus 2bn, right? Okay. So if you just first determine, maybe here, what is the common factors between the 4 terms, maybe 2am, 4bm, 2an, and 2bn, there's no common factors. Maybe common factor is just 1, right? So we cannot extract 1. So here also you can just using grouping method. First, you can make 2am and minus 4bm into a single group. So first, you can extract 2m outside. So here it becomes 2m times a minus 2b, right? Okay. And the second term is negative an plus 2b, right? Also, you can extract 2, maybe extract an n, right? Okay, so here is minus n, here is a minus 2b, right? So now you'll find that they have a common factor is a minus 2b, right? Okay, so here is 2m minus n times a minus 2b, okay? That is for this kind of factorization formula, okay? Okay, that is for grouping with negative signs. Okay, so I believe you have already understand this. So sometimes you first find the common factors. If you cannot find it, just making them into groupings, right? Okay. And here is some deliberate practice for you. Okay, so you can just try on yourself and to find how to do this. Okay. Okay, so if you want to listen to my method to solve these problems, you can also pause the video. Oh, sorry, you can also continue to watch, and I'll help you to solve it one by one. Okay. So first, you can find this formula is about 14 times a squared b minus 21 times ab squared. Okay. So here you can just like maybe for here 14 and 21, they're both a constant number, right? So you can first extract a 7 outside, right? So here is a 7. So you can extract 7 outside. And for a squared b, there's still a 2 times a squared b left, right? So here's 2 times a squared b. And 21 ab squared, we have 3 times ab squared, right? So here is 3ab squared. Okay. So now you can also find a squared b and ab squared. They both contains a times b inside, right? Okay. So maybe here you can just extract for ab. So here is for 7ab, right? Okay. And here we have 2a minus 3b. Okay. That is for these expressions. We can just make it factorizing fully. Okay. So you can now find 2a and 3b. They have only one their common factors, right? Okay. This is for the first problem. And in the second problem, you'll find we want to just expand the formula ax cubed minus 12x squared plus 4x, right? Okay, so you can find they both have 4x, right? So first you can extract the 4x outside. So 8x cubed over 4x is 2x squared, right? And the second term, negative 12x squared over 4x is minus 3x, right? So here is minus 3x. And plus 4x, extract 4x is 1 outside, okay? So that is 4x, 2x squared minus 3x plus 1. But now you can also find that for 2x squared minus 3x plus 1, there still can be factorizing, right? So for 2x squared minus 3x plus 1, you can first divide the 2x squared into 2x and x, right? So here is 2x and x. And for 1, you can divide it into negative 1, negative 1. So the formula here is 2x minus 1 times x minus 1, okay? This is the second formula. And for the third formula you can find, we have both m minus n as our common factors, right? So first we can extract an m minus n outside. So here the equation becomes m minus n, and here we still have 5p plus 2q, right? So here we are using 5p plus 2q as another factors, okay? So for the first problem, we have said like here they doesn't have a common factors for x, y, 4y, 3x, and 12, right? So first we can using grouping method, right? So for x, y, and 3x, you can first just extract the same common factors, that is 3x, right? So 3x, for x, right? Just a common factor only for x. And x here means we have y left and 3 left, right? So here is x times y plus 3. And the second term you can find is 4y plus 12, right? So you can just extract the 4 outside. So it becomes 4 times y plus 3. Now you can find x times y plus 3 and 4 times y plus 3. They both have a common factors is 3, right? Okay, so here you can just extract out. So it's y plus 3 times x plus 4. Okay, that is the common factors right here. Okay, so for the fifth equation, also you can just grouping, right? Like here we have 6px, and here is for minus 2qx, right? So first we can extract 2x outside, okay? So here's 2x, and here is for 3p minus q. Okay, and also for the other two terms, you can extract the 3y. This is a common factors, right? So here you can extract like this 3y and becomes 3p minus q, right? And you can find that both the common factors is 3p minus q. So you can write that as 2x minus 3y times 3p minus q, okay? That is for the common and grouping right here, okay? So you can find it's very easy, right? Okay, so once you understand the principle, first trying to find the common factors for all the polynomials or all the terms. If there's not, just trying to group into like two terms can group in together, or like for 3 or 4 terms, two groups. Okay, that is for this. Okay. Okay, so maybe now let's have a break, please. Okay, let's have a break.